local weather here in DeKalb and around northern Illinois, you'll see the closest weather balloon to us is out in the Quad Cities. So the Quad Cities office over in Iowa is launching a weather balloon twice a day in support of weather forecasting across our region. But again, we have a lot of these, but where we don't have them, we have to kind of guess what's going on in between these data points. Okay, next slide. So what can we do? Once we launch these weather balloons, they're going to radio back data about temperature, pressure in the atmosphere, wind speed and wind direction. And after we feed that data into computer models, which I'll show you next, they can spit back data like this, which is an animation of the jet stream. And we can even forecast things like, what's the radar going to look like, which is a tool that weather forecasters use to track incoming precipitation. This is actually a forecast for the next couple of days as to what the radar is going to look like. So you can see some of the precipitation today is forecast to move out of our area, and we have another batch of precipitation forecast to move in on Sunday. And that's only possible because of these weather balloons that we launch. If we didn't have data above our head, we wouldn't have any idea of what's going on. So they're crucial in support of weather forecasting operations. So how does this all work? We basically treat the Earth as a grid, and we sample and try to simulate points at each one of these grids. So if you can imagine a sphere, and then a volume of that sphere, each one of these little grid boxes, we try to simulate properties of our atmosphere. So temperature, right? How warm is it going to be? Are there going to be clouds? Is there going to be a tornado? We actually try to forecast that as well. So here's what this looks like. These computers are not your average desktop computer, right? These are what we call supercomputers. Most of the time, things like at national laboratories or at our Center for Modeling over in the East Coast. And so these large supercomputers crunch all these numbers, and this is what they're essentially doing. When we launch these weather balloons, go ahead to the next slide. You'll notice these little white arrows going up. These little white arrows are indicative of these weather balloons. As they go up, they sample the atmosphere again, just like I mentioned. Here we are in the field launching one of these balloons next to a thunderstorm to try to gauge whether or not that storm is in an environment that's supportive of tornadoes. Sometimes you find out that the atmosphere is very ripe for tornadoes, other times maybe not so. So that's why these things are so important, and that's what we're going to do today is launch one of these balloons. Okay, so go ahead next. Are you ready to launch? That was pretty weak. Are you ready to launch? All right, let me go ahead to the next. I want to show you just quickly what is going to be launched today so you understand what's going to be on this balloon. The first thing is what we call a radiosonde. This little guy operates on today we're going to be at the 405 megahertz frequency. It's going to radio back to our base station, which I'll show you next. It's going to measure temperature, dew point, wind speed, and direction, and its GPS location, so we can track it and figure out exactly where it's going to be. This thing will go up to about 35,000 feet, so up where aircraft are flying, before it pops and falls back to the surface. When it does that, the balloon will be almost 12 feet in diameter. Right now, it's only about 4 feet in diameter, so pretty amazing. All right, next, so let me show you some of the other things that are going up. The balloon. This is what we call a 200-gram latex weather balloon, so it's nice and thick and durable. As it rises through the atmosphere to an altitude of 10 to 12 kilometers, 35, 40,000 feet, this thing will continue to expand. And the balloon expands. Why does the balloon expand? Anybody know? Yeah, why? Shout it out. Air pressure, absolutely. So as the balloon ascends in the atmosphere, lower and lower pressure, less and less air above it, and the balloon begins to expand. Eventually it will pop when it gets to about 12 feet in diameter. Okay, so next equipment. The base station, so how do we connect and talk to the radiosonde to figure out what's going on? This is our base station, so you'll see this when you go outside. This is communicating, again, on that radio frequency with the radiosonde. That's why we call it a radiosonde, so it's using radio frequencies to do this. And you'll see that out there. This is really the bread and butter. And if you don't have this, you can't talk to the balloon, and then you can't figure out what's it's radioing back. Okay? So, let's go launch. So, I think they're going to kind of shuffle people out. Then when we get out there, we'll do a countdown from 10, and we'll let this thing go.